the Mindset Athlete podcast, and I'm your host, James Roberts. I'm a two-time Paralympian and owner of James Robert Fitness, which is an online training, nutrition and mindset coaching business. First of all, I'd like to thank Lauren Williams for suggesting this quote to the show. An athlete is a mindset. It's how you prepare, think and execute. Not because of some elite status or physical stature. Anybody can be an athlete. By Chris Harth. And each week on the Mindset Athlete, we like to bring you inspirational athletes, a message, or experts talking about human optimization to teach you how to change your perception of your mindset and become 1% better. And on today's show, I welcome back Juma Iraki. Juma is a certified personal trainer from the Norwegian School of Sports Science and holds a master's degree in sports nutrition from the University of Stirling. Juma has also completed his IOC diploma in sports nutrition through the International Olympic Committee. He is also the CEO of Iraki Nutrition and is head nutrition at AFPT in Norway, where he lectures in sport nutrition. So welcome back, Juma.
Thank you so much. I'm glad to be back. It's been a long time.
Yeah, it's been a long time. I think roughly about 2 years. I'll give you the introduction again. Obviously, Juma was on way back on episode 64, where we looked at supplementation, and I've got the notes to my side where we looked at is too much protein a myth? Nitrogen should be where you should have the real concern. What recommendations he has towards supplementation. Obviously, you said vitamin C, omega-3, and vitamin D, what you recommend to your athletes. So obviously I would implore people to obviously go check that episode out as well. So obviously straight off the bat then, Juma, if we touch upon your study that you did with et al. In 2019 in terms of how many meals should people eat in terms of from a protein consistency?
Well, if you look at the research, you can see that there's a lower threshold to how many meals that you should eat because of the protein balance. So in a day, you'll have an increase in protein synthesis, and between meals, you have protein breakdown. So what we want, if you want to build muscle, is that the protein synthesis should be higher than the protein breakdown in total during the day. So the easiest way to visualize this is, and this is not from me, this is actually from one of my professors, Professor Kevin Tipton, because usually when people think about protein synthesis and protein breakdown, they think it as an on and off switch, which is not, because these processes, they are on during the day, but it's more like who's the most dominant of the two. So the easiest way to visualize protein balance is if you visualize a brick wall and you have one person on one side putting bricks on and one person on the other side taking bricks off. If they work like as fast as each other, you won't have any changes in the brick wall. But if you strength train and you eat frequent meals of protein during the day, you'll have an upregulation of protein synthesis, which basically then means that the one person on one side, he'll have maybe a Red Bull or energy drink or something like that makes him work faster than the other person. So during the time, maybe he's able to put on 3 bricks, while the person on the other side is able to take 1 brick off. And then you'll have a higher wall, which basically is your muscle. So like I said, during the day, you'll have increases in protein synthesis, and it's important that you have a minimum of these increases during the day to maximize the effect on muscle hypertrophy, which, if you look at the literature, you should at least have 3 protein feedings during the day. In our paper, we concluded that protein feeding should be between 3 and 6 meals. And most people, they end up eating somewhere between that. Usually I say that sweet spot for most people is between 4 and 5 meals. And the way I do it and the way I recommend that people do is, if you first take the total amount of protein that you need during the day and have a goal of having between 30 and 40 grams of protein for each meal, that should be the basis on how many meals you should eat. So for example, if we take a 100-kilo guy and we say that he needs approximately 2 grams of protein per kg of body weight, that's a total of 200. So the way you would do it is, you'll take the total amount, and then each meal should be with between 30 and 40 grams. And then you keep the meal frequency between 3 and 6. So in this case, you would take 40 grams and eat 5 meals throughout the day. So 40 grams to each meal. The total will then be 200 grams. If we take a female that's 50 kg, like half the amount, and say 100 grams during the day, it would be more. I would recommend that it would be either 30 grams 3 times a day, or you could have some of the meals that are higher. For example, before bed, it's more recommended that you have a higher intake of protein due to a prolonged fast during the night, and you can have smaller meals. But that's the way I recommend people doing it, like trying to figure out how many meals you should eat. You should take the total amount, have a target of between 30 and 40 grams of protein to each meal, and keep it between 3 and 6 meals. The reason why you shouldn't have maybe more meals is that there's some literature that shows that if you eat protein too frequently, you don't have the same robust signaling for protein synthesis. So it's called the refractory response of protein, where if you eat proteins frequently in a short amount of time, the protein synthesis doesn't get that same robust increase. So I think Bo and colleagues did this study in 2001, where they showed that if you tried to stimulate protein synthesis 2 hours after a meal, you didn't get the same response for protein synthesis. So it's recommended that it should be a longer period between the meals, like 3 hours or more, so that the protein synthesis can go back to baseline, and then you try to increase it again. I'm not a big fan of trying to complicate things too much. That's why I'm saying that the easiest way to do this is try to think of total amount of protein, 30 to 40 grams of protein per meal, and try to keep it between 3 and 6. I would also like to add one more thing, and that is importance of protein quality, because there is a difference between protein that comes from plant-based sources and proteins that come from animal-based sources. So the 30 and 40 grams protein recommendation, what I usually tell people is that try to at least have 2/3 of that coming from a complete source. So example, if you were to eat 30 grams of protein and you're eating, let's say, a sandwich for lunch with some cheese and ham, if 20 grams is coming from the bread and 10 grams is coming from the cheese and the ham, that's not optimal. Even though it's 30 grams of protein, it's not the optimal way of doing it. But if 10 grams come from the bread and 20 grams come from the cheese and ham, that's more optimal doing it that way. So you have to also think about the protein quality, not only because a frequent question that people ask is, should I count all the proteins that I eat that comes from bread and grains and stuff like that? And I say yes, but try to have it in the back of your mind that most of the protein that you eat should come from a high quality protein source, and then the last third of that can come from an incomplete source.
You raise a good one. I never thought about that in terms of, it being, the secondary macronutrient within a product, like you say with bread, because you would normally associate that's, well, I know it's not completely carbohydrate, but its primary function is to obviously serve as a carbohydrate. Mm-hmm. So you were saying where does that bias come from of the on and off switch? Does it come more from the training aspect of it then? The resynthesis and actual protein breakdown then?
Well, the thing is that Lane Norton also have a good way of explaining it, that when people think about protein synthesis and protein breakdown, they think of on and off switches, which is not. It's who is the most dominant. So it would be, protein synthesis would be more dominant when you've exercised, when you're eating your protein feedings, and between meals, there's something happening, right? There will be breakdown to from amino acids to supply the demands of the body. So you'll have, it will look like peaks and valleys in a sense, where you'll see that when you eat proteins, when you strength train, there will be more dominance from the protein synthesis side, and protein breakdown will still continue happening, but it wouldn't be as dominant. That's why I was explaining the things with the brick wall, where it's always on, it's always ongoing, but who's the most dominant?
Well, I think it's a good analogy to use, because you can visualize that, even though I have the bonus of being able to see what you're doing with your hands and things like that, whereas people listening have to kind of visualize. So I think you utilizing the brick wall, I think people probably creating a story inside their head as, Juma's building a wall.
Yeah. I actually use this analogy, like this metaphor, when I also talk about the effects of anabolic steroids, because anabolic steroids, they have, and the reason why they are so effective for building muscle is that anabolic steroids has a double effect. It increases protein synthesis, but it also reduces protein breakdown. So I was saying that when you were resistance training and eating protein, it was almost like the one that was putting on bricks on the brick wall, got a Red Bull or an energy drink, and was able to work faster. But when you're using anabolic steroids, it's almost like you would give a baseball bat to the other guy, and he would beat the shit out of the person on the other side, so he could actually work on his own without any interruptions. That's actually how effective they are for building muscle.
Well, obviously, you don't advocate for people to use the
Absolutely not. But it's absolutely not. It's more about when people say that they're not that effective and that you have to train harder. And usually people ask about protein requirements, because you see these high-level bodybuilders, they eat a ton of protein, and people say, well, that's because they use anabolic steroid. And when you eat anabolic steroids, you need higher amounts of protein. It's actually complete opposite, because since you have an increase in protein synthesis and a decrease in protein breakdown, the protein requirements is actually lower when people are using illegal drugs like anabolic steroids, due to the double effect that you get from it.
So they're getting like a double hit then of not having the downsides of a normal human being, of having that breakdown then. So that's the muscle is kind of got like how would I describe this? A double effect through the muscle synthesis then. So they get like a double hit, but not having to have that trough that you described then.
Exactly. It's the same thing with weight loss. Like people have this idea that carbohydrates is bad and insulin is bad due to the fact that insulin reduces fat oxidation, which is true. Like when you eat food and you have an increase in insulin, the body's not burning off energy. But it doesn't make sense that the body is supposed to burn off stored energy when you're actually supplying the body with energy. But it's what's happening between the meals. So when you eat food, you'll eat food, store energy. Then in between meals, you'll have a release of energy. So you're storing, releasing, storing, releasing, storing, releasing during the day. At the end of the day, you look at the balance and see, did I store more energy than I burned, or was it the opposite? And that will determine if you have any changes in weight and in body fat. So people need to stop looking at the body as some like static system, because it's not. It's very dynamic. There's storage and release of energy happening throughout the day. But when people see that, oh, when you eat food and when you eat carbohydrates and insulin, and that stops fat oxidation, that means that that's the reason why we get overweight or put on weight, which is, it's not. It doesn't make sense that the body is going to use the stored energy in the body when you're supplying energy. But then again, you have periods during the day when you're not eating and the body still needs energy. Where do you think the body takes that energy from? It's from the stored energy.
Do you think that comes from misinformation out in the wider media, or be it, I think as a society, we're in it for the quick fix or the get rich schemes, where we're talking about off air, and I'll put it in this one as well because it'll go out later. I did a video as of today we're recording about obviously things that I stand against with companies saying that you can get into ketosis or rapid weight loss, and this product is either in a powdered form, a pill, I can't think of anything else, but there's probably something I'm missing. And obviously people will jump on the bandwagon of these products because of the quick turnaround of obviously the goal or outcome they want to achieve, be it probably most notably weight loss. And they will spout out sometimes, well, I learned something and I'm quite happy to share that with the audience in terms of we are all born in ketosis. I didn't know that. It obviously triggered me to kind of say, well, I don't think that to be true. I was proven wrong, whereas where I deem that information to be misleading is I've gone away and looked at the research, and the only way a baby can be in ketosis is if the parent is taking ketosis, which probably from a medical standpoint, a doctor would not be too pleased with the mother being in calorie deficit, with obviously having two people to feed. But obviously that's a different topic altogether. So I think where this is probably misleading and where people get probably skewed or fixated on these magical numbers where, oh, this person was able to lose enormous amounts of weight, comes back to your point of energy out, energy in. If you're only drinking your nutrients and ultimately your food, this is where probably common sense needs to prevail. You're bound to lose weight because you're not getting the same amount of calories you were doing eating whole foods.
Mm-hmm. Yeah, because one of the things that I try to teach people that want to lose weight is that at the end of the day, it's everybody, like most people know that to lose weight, you have to be in an energy deficit. So on paper, it's easy, but in practice, it's not, because the hardest, like if you look at statistics for people that lose weight and keep the weight off, it's pretty bad. It's like 95% of people that lose weight regain the weight within 5 years. And one of the things why they fail is because of hunger. So one strategy to combat hunger is trying to focus on food that provides high satiety. So, for example, I always use this example that if you compare bananas to, for example, blueberries, you're able to eat like 3 times the amount of blueberries compared to a banana. I'm not saying that bananas are bad. I'm just saying that when you're in an energy deficit, there's some choices that might be better because they're more filling to your system and will lead to a higher satiety. Because the body or the digestive system, it doesn't react to satiety from the amount of energy that you're eating. It's the amount of stretch that's on your stomach. So technically, I could take a balloon, blow it up inside your stomach, and it's not providing calories, but you're getting a stretch on your stomach, which will then signal that you're full and feel satiated. So if you're able to like have these strategies of choosing foods that are filling, that's one of the best strategies that you can use to stay full even on low calories. Because again, that's one of the things that people struggle with. If a diet is making you chronically hungry, you might be able to sustain that for a week, a month, maybe 3 months, but in the long run, it's not going to work. You'll come to a point where you can't keep on fighting that hunger. And that's why people struggle. That's one thing. The other thing is that for sustainable weight loss, you have to think of a strategy that you're able to sustain in the long run. So when people go on these crash diets, I always ask them, you have to, when you're trying to lose weight, you have to like think about when you've lost weight. Like say you're going from 100 kg to 90 kg, you have to sustain the same things that you've been doing to get to 90 kg to keep the weight off. So if you're already struggling with the strategy that you're using because of you're doing liquid diets or cabbage soup diets or stuff like that, it's not going to work in the long run. And the downside of doing these crash diets is also that over time, and this is actually one of the areas that I've done some research, is that over time, if you keep doing this, every diet will be harder and harder and harder because there's a downregulation of your resting metabolic rate. So let's say you started at 100 kg and your resting metabolic rate was 100%, and you went down to 90 kg and your resting metabolic rate went down to 90%. And then you finished the diet and you went straight back to 100 kg. Your resting metabolic rate is not going to go back to baseline as fast as your weight. So while your resting metabolic rate is normalizing, you've decided that you want to do another diet. So let's say this time you're starting at 100 kg and your resting metabolic rate is at 90%, and you went down to 90 kg again, and this time your resting metabolic rate decreased to 80%. If you keep doing that over time, your resting metabolic rate will be lower and lower and lower and lower. And that's what I see quite a bit with a lot of people that have been doing this yo-yo dieting over time, is that their resting metabolic rate is much lower than should be expected. So at the gym that I work at, I actually have a lab where I do indirect calorimetry, which basically is you lay on like a reclined chair for 25 minutes with a mask, and then we measure how much oxygen you're consuming. So for each liter of oxygen, that equates to 5 calories. And then the system or the metabolic cart, it will calculate how much this will be during a 24-hour period. So your resting metabolic rate is the amount of energy that you expend without doing anything, because there's still processes going on with your kidneys and lungs and stuff like that that requires energy. And what I see a lot is people that have been doing yo-yo dieting over time, their resting metabolic rates comes back at 80%, 75%. The lowest I've actually had is 64%, which is really bad because it might take some time to normalize your resting metabolic rate. It's not a permanent damage to your system, but it requires that you're not in an energy deficit over time. So you might have to go in the opposite direction for some time to normalize everything and then try to lose the weight again. And I've had clients that we expected them to have a resting metabolic rate at 2,100 and it came back at 1,500. And within a year, we were able to get them up to 1,800. So it takes some time to do this, and you have to do it in a very strategic way to reduce the risk of gaining too much weight, because calorie wise you have to actually go in the opposite direction. which can be a bit frustrating for the person because their goal is to lose weight. And now I'm telling them, you know what, in the long run, you will benefit more from allowing your body to normalize and then trying to lose the weight. Because if we were to try to diet at this point, we would just end up reducing the metabolic rate more and more and more and more, which again makes it difficult to sustain weight loss.
Why do you think then, Juma, that there's an objection to go the opposite way, going to a calorie surplus when ultimately I deem you an expert with having more qualifications than myself? Why, as a society, do they not agree with your recommendation?
Well, I think for most clients, it's been more the idea of, well, I'm trying to lose weight. Shouldn't I be in an energy deficit? Well, if we're going to lose weight, you have to be in an energy deficit. But I'm trying to think long-term here because I know that to normalize your resting metabolic rate, we have to allow your body to recover fully, which you haven't done because you've been doing all these frequent crash diets. So it's not sustainable in the long run, because in this example, let's say I have a person that their resting metabolic rate is 65% of what is expected, and I diet them down even more, and we end up resting metabolic rate at 60%. That would require too low of a calorie amount for them to sustain in the long run. So either we take some time to recover fully, and then we do it in a more strategic way to lose the weight, or this will keep on being a vicious cycle where it makes it more difficult each time you try to diet down. There was even a study by, I think it was Kevin Hall, not Kevin Hart. I almost said Kevin Hart, but that's the artist. Kevin Hall. He's done a lot of studies on overweight people. And one of the things that he saw was, do you know the show The Biggest Loser?
Yeah.
Yeah, so like 95% of the contestants at The Biggest Loser, they regained all the weight again. And they had like massive weight losses. And what they saw is that the participants where the weight, they put back on the weight, they measured the average resting metabolic rate from when they started and after they regained the weight. And the difference was I think it was 503, don't quote me on that, but it was slightly above 500 calories on average, lower resting metabolic rate than when they started. So you're basically burning a Big Mac less a day, even though your weight went back to what it was when you first started dieting. So this time, if you're trying to lose weight again, you either have to eat 500 calories less than that or exercise more, like expending 500 calories more during the day.
And obviously you mentioned earlier in the episode about obviously comparing the blueberries versus the apple, the banana, sorry. Do you think it comes back to, from your opinion, there's less, and to a certain extent, dietary fiber gets overlooked?
Yeah, absolutely, because dietary fiber is not sexy enough for people. Like people are more interested in proteins and carbs, and people focus a lot on protein, which they should do. And I'm glad that we finally have reached a point where there's more available high protein foods, which makes it easier for people to get sufficient amount of protein. But I think dietary fiber gets overlooked, and especially in the fitness community, I see people that they track their protein, carbs, and fats and total calories, but they don't pay attention to fiber. And fiber have several benefits. Like fibers are nutrients for the gut bacteria that we have. They regulate keeping stable blood sugar levels. They keep us regular so we don't get constipated or have diarrhea. So there's several benefits to dietary fiber, and it also has beneficial effect for cholesterol and heart health and stuff like that. What I typically recommend is that for every 1,000 calories that you eat, you should at least have 10 grams of dietary fiber. But there's also an upper limit to how much fiber I recommend. So I usually recommend that people eat 10 grams of fiber per 1,000 calories that they eat. But upper limit is 50 grams of dietary fiber each day. And the reason for that is if the intake of fiber gets too high, fiber has a tendency to transport a lot of stuff out of the body. Some of the stuff are good that it transports out of the body as waste, but it also has the potential to reduce the absorption of vitamins, minerals, fatty acids, and stuff like that. And that's why I keep an upper limit to how much dietary fiber you should consume. Also, when you start to go into the 40, 50 grams range, area, people have a tendency to get some digestive issues from that. So for most people, they end up consuming between 20, 30, 35 grams of fiber each day, which isn't too hard if you focus on eating enough fruits, vegetables, berries, whole grains, and stuff like that. So especially for people that follow, like, if it fits your macros, flexible dieting, I always, when people approach me and want to follow that, just so their diet doesn't end up just being Ben & Jerry's and Pop-Tarts and protein shakes, I usually give them, tell them, okay, if you're going to follow this, these are your macros, but I also want you to have a target for your dietary fiber, which is X amount of grams each day, and also have a target to how much servings of fruit, vegetables, and berries you should eat every day. I don't know how the recommendations is in the UK, but here in Norway we have recommendations of at least 500 grams each day. And there's actually studies showing that if you eat more, there's more health benefits to eating fruits, vegetables, and berries each day. I think one of the studies that came out now, they showed that if you ate 750 grams each day, you saw more benefits from consuming that compared to 500 grams. So is it 500 grams in the UK that you usually recommend, or?
I think in the UK, most people fall short of the 20 grams a day. And I think it's over 50% of the population. So it's a lot of people need to recheck their obviously dietary intake. And obviously what I didn't mention in that video, and you pointed out, is if people are going to those extremes of using liquid diets or juicing, which I had an argument with somebody, I think a couple of weeks ago, in terms of, it's good that you deem it to cleanse out the body, which is to a certain extent ridiculous because the body itself does it. But obviously all the fiber that you're then losing through juicing, because all that becomes the pulp after it, where you're consuming, if we just use fruit as the example, probably consuming more fruit than you'd be able to eat if it was in its whole form. Thus, you're consuming more calories, more sugar, and obviously that's going to spike your insulin and all that, and obviously your insulin sensitivity. And I think where you mentioned in terms of the fiber, where people obviously want to have their goal of the weight loss being the optimal, which is fair enough, because ultimately you want to change or transform your life from where you're at presently, which we laud and commend you for doing that change. But you are taking out a necessity, like you said, Juma, obviously, that all the health benefits that the fiber gives you. And I think the more we educate people to make the decisions for themselves long term, I think it's better as a society as a whole. The more we educate people about, I won't call it proper nutrition, but nutrition habits that you can maintain long term, I think we won't have these. I think they'll still exist, because ultimately it comes back to the money is king, and ultimately most people think about the green versus and I mean financial green, not vegetables, versus probably the long-term well-being of oneself. And I think where you said with the fiber, most people need to look at it. It's I would probably say Scandinavia is probably one of the healthiest people on the planet. You might disagree to a certain extent, versus maybe the UK, and especially because this is much as big in the US, that their decisions are made probably sometimes on impulse, or television has a lot of sway over what they consume, not just with food, but with everything, because of propaganda, good marketing, and advertisement.
Yeah, and like one thing that is like you touched upon the financial part of like with nutrition and stuff, and to a certain extent there is some truth to it, because if you look at recommendations for nutrition and you compare different countries, you'll see that there is some differences in what is recommended, and that has to do with what type of resources do we have available in the different countries. So in Norway, we recommend a lot, like dairy is often recommended, like consume 3 servings of dairy each day. And that's because we have good access to high quality dairy in Norway. Like in Norway, the cows, they eat mostly grass. So it's grass fed. And if you look at United States, they're always advertising these products like whey protein, grass fed. And it catched up here in Norway with people like saying, well, I'm going to start buying grass-fed beef from these special stores. And I'm like, well, everything is grass-fed in Norway. What are you talking about? But they're comparing it to, because it comes from TV and articles and advertisement from the States. But in the United States, cows are not grass-fed. They're consuming soy and corn and stuff like that, which is basically not healthy for the animal, because you suddenly have a different fat profile of the meat that you're eating, because it's not natural for the cows to eat those sort of things. That like naturally it's grass that cows are supposed to eat. So to some extent there is some variation in what the nutrition recommendations are in the different, but I would say that if you look at it globally, I would say that 70%, 80% of the recommended, they're pretty unanimous in what you should be eating more of and what you shouldn't be consuming too much of.
So obviously coming back to the one we alluded to when you're talking about protein, Juma, why do you predicate not using whey as your source of protein lasting at night versus what marketing will tell you vis-a-vis, having casein as the form of the supplementation for protein lasting at night?
Well, it has to do with how fast the body is able to break down different protein sources. So whey is rapidly absorbed in the body. Usually you see a peak in protein synthesis from dairy at the 2-hour mark. And that leaves a substantial amount of time during the night where the body is not getting sufficient supplies of amino acids. So better sources would be like casein sources, and it doesn't have to be casein powder. You could eat stuff like cottage cheese, for example, Greek yogurt, stuff like that, which takes a substantial more amount of time to break down in the body. So that would give you a supply of amino acids throughout the night, where you have a lot of hours where you're not consuming nutrients. Whey is pretty good consuming post-workout or pre-workout, because you get a rapid increase in protein synthesis and a rapid supply of amino acids. But what I actually recommend I'm not a big fan of using whey straight up. So what I typically use is I'll recommend people to have a blend of whey and casein, which is what it naturally is when it comes from dairy. So in dairy, you have 20% whey and 80% casein. And the benefit of that is that with the combination of the two, you'll have a rapid increase in protein synthesis from the amino acids that rapidly digested. And when the whey has done its job, the casein will take over, which is a benefit. So they help each other out in a sense. So what I typically recommend people is that consuming whey with milk, you approximately get a 50% ratio between whey and casein. But pre-bed, a typical meal that I recommend a lot of people is using cottage cheese, oatmeal, and blueberries combination. And the reason why I also recommend oatmeal is that we give oatmeal to kids for a reason, because the oatmeal has a tendency to make you more relaxed, and it's easier to actually get some high quality sleep. So a lot of people that I have that struggle with that have sleep problems actually see a benefit from consuming oatmeal and cottage cheese before bed. And it's not coming from the cottage cheese, obviously, it's coming from the oats, but just a little tip there for people that are struggling with sleep. Consuming oatmeal before bed might be of help.
So what would you do for obviously the population that is kind of stemming towards, I won't call it a trend now because it's becoming a lifestyle choice, veganism, where that's going to be able to get your proper sources of protein is very much more difficult for somebody being a vegetarian or a vegan because of their ethical reasons towards.
That's a good question. Like we previously talked about that there's a difference in protein quality when you look at animal sources versus plant sources. But that doesn't mean that there's no benefits of plant-based protein. It's just that you have to compensate for the lower quality by consuming more. So I think there was a study from it's not Long. It's DeVries and Phillips in 2016, 17. I don't remember, but DeVries Phillips had a study where they compared 25 grams of whey protein, rice protein, soy protein, and they looked at which one of them would reach the leucine threshold, which is basically what we're trying to achieve to maximize protein synthesis for each meal. So there's different leucine contents in different protein sources, whey being the king of all protein sources because it has the highest leucine content. But what you actually saw in that study was that when you compare 25 grams of rice, soy, and whey was the only one that was able to reach the leucine threshold. But then they compared higher doses of rice and soy protein, and 50 grams of soy protein had the equivalent effect on protein synthesis as 25 grams of whey. So you still reach the leucine threshold and got the effect on protein synthesis, but you just have to consume more. So what I typically do with vegans, because I have some clients that are vegans, is that I recommend that they increase their protein intake by 20 to 25%. So we compensate the lower protein quality from plant-based sources by consuming more. So typically if there was a 100 kg guy typically eating 200 grams of protein, we would increase that to 220, 225 based on the fact that he's vegan.
That's interesting. Do the extra numbers scare people at first then?
Well, sometimes yes, because for vegans, it's difficult to increase the protein amounts in their diets and still have, let's say, for example, if you're doing a weight loss phase, it's difficult to have a high protein intake and keeping carbs and fats low if the goal is weight loss, because when you're eating a lot of plant-based sources, you also get a substantial amount of carbohydrates from the sources. So it's not that easy compared to eating animal-based protein sources to eat sufficient amount of proteins without getting X amount of carbs when you're eating the different sources. So that might be a challenge for some people to get the protein amounts that high and still keeping carbs and fats in check.
So they have to be a little bit more adaptable and flexible to their dietary needs versus, say, somebody that's, I won't say normal because that's offensive, be it that's getting their sources from animals.
Well, you have to be more. Focus more on the sources that you're eating. And one of the challenges that I sometimes have with vegans is that they don't have quite the variety of food sources that they eat, even though they're eating sufficient amounts of fruits and vegetables and berries and stuff like that. Usually they have a bit more struggle with variation in their protein sources due to the fact that it doesn't have the same variety as if you were eating animal-based protein sources. So that might be a challenge sometimes. And also one of the things that might be like underestimated is that it's, even though vegans eat a lot of vegetables and stuff, it's quite challenging for them oftentimes to get sufficient amount of everything. And that might have to do with the limitations they have from different food sources, because they don't eat animal sources. But it also has something to do with the bioavailability of a lot of vitamins and minerals that you found in plants. They're not as easily absorbed as vitamins and minerals you'll find in animal sources. So example, iron that comes from red meat and animal sources has a much higher bioavailability, so it's easier for the body to absorb it compared to iron that comes from, let's say, spinach. Spinach has a lot of iron in it, but if you eat the spinach raw, there's a lot of stuff in the spinach that will hinder the optimal absorption of spinach. So the net amount of iron that you're getting from raw spinach is quite low. So you'll have to cook it or do something with it, like heat it or stuff like that, to actually maybe make it more absorbable for the body. While a steak, you don't have to basically do anything with it because it's so easily digested and absorbed by the body. So that's why, like, typically we'll say to athletes that when you're eating grains, or not athletes, like general population as well, when you're eating grains, you should have a vitamin C source in there, because that will help the body absorb the iron from the grains that you're eating. So it's, say, for example, you're eating a whole grain sandwich for lunch. It might be a good idea to eat an orange or something with vitamin C in it, because it helps to absorb the iron from the grains that you're eating. But you don't have to drink orange juice when you're eating a steak, because it doesn't need that help.
So from that basis then, I think it's Disney. Popeye is very manipulative then, because, you know, he's eating the raw spinach out of the can. So is that very much fiction versus fact in what you're talking about then?
Well, yeah, it is, because, like I said, as long as, like, you'll have to make some, you'll have to do something with the spinach to maximize the absorption of it. Because I see too many people, they throw in raw spinach in their smoothies and stuff like that, and I'll tell them that, well, that might not be the best idea. It's better if you boil it or stuff like that, because then you'll remove some of the chemicals that are in spinach that hinders the absorption of a lot of the micronutrients that are in there. But the same thing you'll see with, it's not exclusively just for plant-based stuff. You'll see the same thing with some animal sources. A lot of people use raw eggs in their smoothies or eat raw eggs in the morning. But if you look at the absorption of protein from raw eggs compared to cooked eggs, there's quite a bit, there's a huge difference in the amount of proteins that gets absorbed. So if you cook eggs, you'll absorb 93% of the proteins, while if you eat it raw, there's only a 56% absorption of the proteins. So almost half the proteins are wasted when you eat raw eggs compared to cooked eggs.
Does that not come from, be it seeing, obviously, bodybuilders in the past doing it, be it like Arnold Schwarzenegger, just to name him, but obviously multiple people within, obviously being big and being for a, I won't be gender specific, but be it if somebody wanted to become that way inclined to be more aesthetically pleasing, do you think it's a bias to what historically has been versus actually evidence being in actually from a scientific perspective?
Yeah, absolutely. And I think not only bodybuilders, but people like Rocky, Sylvester Stallone in the Rocky movies used to do that, and people would see that. Hulk Hogan, famous wrestler, used to do that. Like, the funny thing is that, like, for me as a nutritionist, I'll see a video of Hulk Hogan talking about he's taking eggs, eating them raw, mixing them with Red Bull in the morning before he goes to training. And in one of the videos, he actually says the reason why he eats raw eggs in the morning is because there's no carbs and no fats, only proteins in them, which is not correct, because the yolks has quite a bit of fat in it. So it's just like basic knowledge about nutrition is like non-existing with some of these people. And still people see this and they'll try to eliminate, do the same thing as them.
So obviously you mentioned iron, and it moves me nicely to the next question I've got for you, Juma. Are active women more susceptible to iron deficiency?
Yeah, and there's different reasons why they are. First off, women don't have the same levels as men when it comes to testosterone. So testosterone stimulates to increases in red blood cells. That's why men are not as at risk for iron deficiencies as women. So that's one reason. Another reason is like menstrual cycle. Women of natural causes, they lose blood during the month when they have their menstrual cycle. And women have, like females, has a tendency to not eat as much red meat and other good sources of iron. So dietary iron intake seems to be lower in females compared to men. But when they're trained, there's also something that we see that are different for females compared to males. They have a tendency to lose more iron through sweat, decreases in red blood cells when they exercise, especially if they're doing a lot of endurance exercise. They have more like these microscopic bleedings in their digestive system, so they actually lose blood from their feces as well. And another thing, and this is not exclusively to females, it's for both males and females. When you exercise, you have an increase in a hormone called hepcidin. So hepcidin, it actually hinders the absorption of iron. So what we teach these athletes is that if you're iron deficient or have a tendency to get iron deficiency, the iron-rich meals and the iron supplements that you take should be as far away as possible from your training sessions. So it's not a good idea to do a training session and then have your iron-rich meals or supplements taking shortly after the workouts. So I think it's 6 or 8 hours that they should be away from the training session. So that's also one area you should focus on to maximize the absorption of iron from the food that you eat. That try to eat your iron-rich meals as far away as possible from your training sessions, so it doesn't get affected from the increase in hepcidin after exercise.
That's very interesting in terms of why. Obviously, this is for me out of curiosity as well. And Juma, why does from the bleeding from a digestional affect only women and not men?
Well, that's a good question, and I don't think I have a good answer for that. It might, like, it's not exclusively for females because it happens in men as well, but you see a tendency that they have an increase both in that and also in sweat losses when it comes to iron. And some sports are more prone to iron deficiencies, and that has something to do with the type of activity that you do. So, for example, doing endurance exercise like running for a marathon and stuff like that has a tendency to use more red blood cells, which then again make you more prone to having iron deficiencies. But why women are more prone to that compared to men, I don't have a good answer for that.
I appreciate your honesty with that. That's probably for something for you and I to maybe research further into, and then obviously get the answer for.
Absolutely.
So obviously I say to anybody listening to this episode, that's probably something to hold us both accountable for. Have you done the research and found the answer to that question? Mm-hmm. So moving on to my next one for you, Juma. In terms of water, and this is what I found very interesting reading one of your posts with it, is why is this premise towards 35 milliliters per kilo per day in terms of your water consumption?
Well, there's no research showing that. That's just a practical number for most people to follow. Because one of the things that's difficult with giving fluid intake recommendation is that it can vary quite substantially based on the type of exercise you're doing, the type of duration, like the duration of the exercise, the type of climate that they're training in. And some people are more prone to dehydration due to the fact that they sweat more than other people. I think a lot of people have this, they're a bit misguided in water intake because they think that the goal is to drink as much water as possible. You're actually just trying to be in fluid balance, so you're just replacing the water that you lose from primarily urine. You lose it from sweat. You lose it from your feces as well. And the intake primarily comes from fluid that you eat, breakdown of glycogen stores that actually frees up water in the body, and also from the foods that you eat. So a lot of fruits and vegetables, they actually supply with the water intake. So if I were to give more specific tailored to an athlete, it would be more to do different types of tests. Like we would weigh you before exercise, see how much you drink during a session, weigh you again after exercise, look at the differences in weight, and based on that, we could calculate how much fluid you should drink during your session. But for most people, it's a bit too complicated to do that. But the reason to give this recommendation is that I see too many people at the gym that carry around like 3-4 liters water bottles and they jug it down. Something like that. And where does that come from? They'll see these bodybuilders doing that. And I'll ask them, well, do you think it's reasonable that you as a 70 kg guy is drinking the same amount of water as a bodybuilder that weighs double amount of what you weigh? No, it's not it's not logic at all. So there's different types of recommendations for fluid that you often hear. Some people would say drink 3 liters, 4 liters, 2 liters, but it's not a recommendation that's based on the size of the person you're giving it to. So for example, 3 liters for me might be enough, but it might be too much for a female weighing 50 kg. So that's why it's better to give recommendations based on body weight than to give like these broad general recommendations that it's supposed to be for everyone. But my best recommendation is actually, this recommendation is based on, like, to give you a practical number of approximately how much fluid you should take in. But a better recommendation is actually to look at different things and then based on that try to estimate how much fluid you need. So what I typically do is I'll tell people to look at how many times, how frequently are you urinating during the day. If you're going to the bathroom 3 times an hour and the stuff that's coming out of you is as clear as water, you're obviously drinking too much. If you're always feeling full and heavy after drinking, you're obviously drinking too much. So you should frequently go to the restroom during the day. There should be no smell when you urinate, and the color should be not as clear as water, but a light yellowish color. If it's dark as beer, you're obviously dehydrated. But if it's clear as water, you're obviously drinking too much. So look at the frequency of how many times you're urinating during the day. There shouldn't be any smell, and the color of the urine should have a light yellowish color. So if you use that and try to estimate how much fluid you should be drinking, that's actually better, because that also takes into consideration when you have variation in climate, which can, like, fluid recommendations or fluid requirements can vary a lot based on climate, and like I said, type of exercise, intensity, duration, and stuff like that. So having a recommendation like this will adjust based on the activity that you're in. And while we're on the topic of fluid intake, and I will also, I don't know what type of salt, like, how's the salt recommendations in the UK? Do you have any recommendations for that?
Oh gosh, that's a good question. You asked me that. The recommendation for, I don't actually. I have to look that up. For what it is in the UK, it's because most people focus on the sugar, not solely, but there's obviously a bias towards that right now, and I think people forget about salt or sodium intake overall. And I think, would you mention in obviously exercise, obviously sweating from a female perspective, and having a rationale towards iron deficiency. Obviously, hydration is paramount for that, from the sodium within water, and then whether or not you need to supplement that with either table salt for doing kind of at home isotonic drinks like that, to be able to make your own, which I think some people don't even know that you don't have to buy it from a shop to be able to do it. And when I've given those to clients, it's like, it's not rocket science. And these are articles from the BBC, probably about, off the top of my head, probably about 10 years ago, because you can say how the website has been archived. But to answer your question more specifically in terms of, let me Google it while we go. But let me ask you from a Norwegian perspective then. Well, what's the recommendation in Norway? Well, I pull that up.
Well, in Norway, it's recommended that you keep it under 5 grams of salt each day, and we average see that people are consuming double amount of that. And it's a good recommendation if people are like people have high blood pressure, but it's not a good recommendation if you're an athlete or someone that like exercising a lot, sweating a lot, because low salt intake is not good as well. So, and it can be extreme how much salt you can lose, like how much sodium you're losing, because the function of sodium in the body is that it regulates the blood volume, it regulates the heart frequency. So when you've probably seen like marathon runners coming in at the finish line and they collapse, and people are like, oh, it's probably because they're dehydrated. It's not because they're dehydrated. It's actually because they drank too much fluid, so they ended having a low concentration of sodium in their blood, and they started to feel like powerless. They started to cramp. They started to feel fainted and stuff like that. So sodium and water, people focus on water, but they should also focus on sodium, especially if they exercise a lot. And one easy test that you can do, because we have something called a salty sweater, where people actually lose a lot of salt in their sweat. So if you take a black t-shirt, exercise, and then look on the inside, if there's some white powder under the arm or the chest, it indicates that you're probably a salty sweater, because the white powder is salt. And if that's the case, you should probably focus more on your salt intake pre-exercise, maybe also consume more salt during exercise, especially if you have a tendency to cramp. And when I lecture and talk about salt intake, because people say, well, aren't we supposed to reduce the intake of salt? And I tell people, well, you have to take into consideration that the recommendations that comes from the government it's based on trying to like reduce risk of like diseased populations. So people that have high blood pressure should and probably will benefit from reducing their sodium intake. But it's not a good recommendation if you're a high level athlete, exercising several times a day, sweating a lot. And there's actually a good study to illustrate this. There's a study from Golek from 2011 where they actually measured fluid loss and sodium losses for NFL football players during a training session. So they were exercising in, I think it was 27, 28 degrees Celsius, and the training session was 4 hours long. So the biggest guys on the team, they actually lost 32 grams of sodium during that training session, and they had a sweat loss of 10.1 liters, which like it's extreme how much you can lose sodium and how much you can sweat if you're that big, exercising for that long in fairly warm climate, like 27, 28 degrees. And you have to also take into consideration that these guys use a lot of equipment when they exercise, with the helmet and the patches and stuff like that they have on. But it can be that extreme. And I can assure you that if it was a case where these guys were to consume less than 5 grams of salt during the day, they would cramp up and feel like shit, and would like be at risk of actually having some health problem, because it can affect the heart rhythm if the salt intake gets too low, like even through low sodium intake, or if you actually consume too much water and the sodium level in the blood acutely is too low.
Obviously, I've done the research as you asked. Our government guideline is 6 grams per day.
6 grams of salt. Okay, so approximately the same as the recommendations in Norway.
So if I move on to the next question for you, Juma, that I've got down in my notes. It is often claimed that too much protein can be harmful to the kidneys.
Mm-hmm. Well, that claim is based on like people that have renal failure, like kidney failure, one of the treatments is actually to follow a low protein diet. So based on that, people assume that the cause of kidney problems is coming from consuming too much protein. But we have now, there's Walser had a review in 1999 where he actually claimed that low protein diets can actually be the cause of renal, reduced renal function. Because you have to think of proteins, it's not just for muscle, it actually helps to repair all other organs in your body. So if you're eating too low of protein, one, you're not getting the building blocks to keep everything functional. And another thing is that since kidneys handle the breakdown of protein and the waste and stuff like that, if they're actually not exercised in a sense, like the same thing as if you don't exercise your heart hard enough, it can have detrimental effect to your overall health and your heart health. It's the same thing with the kidneys, that if they it's like if you don't use it, you lose it. Same thing with the kidneys. But there's several reviews lately that's come out in meta-analysis showing that for healthy individuals that don't have renal failure or aren't predisposed to kidney diseases, there's not issue with following high protein diets. So Dr. Jose Antonio in Florida has done quite amount of research on this area where he's actually used super high protein diets. There's one study where he did 4.4 grams of protein per kilogram of body weight. And I think he did a study where they were consuming approximately 3 grams of protein per kilogram of body weight, which is super high. And they did that for a whole year. And he did it for another year, like 2-year study where they were consuming these high amounts of protein. And they didn't see any changes in renal function whatsoever. Like renal function was exactly the same.
And then obviously from a creatine perspective, why is it, or should I say, why is reduced kidney function an issue when taking creatine?
Well, the thing is with creatine is that when you consume it, like the waste products from the kidneys is called creatinine. And when you take creatine as a dietary supplement, it has a tendency to increase the creatinine in, like if you did a blood sample and you checked your creatinine values after starting to take creatine, you would see an increase there. But you have to understand that when you look at kidney function, creatinine is not the best marker to look at it. Like if you look at that and also look at, I don't know what it's called in English, but in Norway we call it GFR, which is the filtration of the kidneys, like how good they are at filtrating and cleaning. That is a better marker for kidney function. So if you see GFR, which is normal, and creatinine levels that are slightly increased, I wouldn't be too concerned about that. But if you see that your GFR is going lower and lower and lower and lower, I would be more concerned with that. And you have to I also would like to mention that the reason why creatinine is such a bad marker looking at it isolated is that it also gets affected from a lot of other things, like the food that you eat. So if you have a high protein diet, you will see an increase there. Dietary creatine, when you take that, you'll see an increase in creatinine, and also exercise. So actually, if you measured your creatinine levels one time without doing any exercise, and then you went on and did exercise, and then you measured again, you would see an increase in that. So you have to know about these things. That's why medical doctors not always are the best at looking at bloods for athletes, because they don't know about the effects exercise and diet can have on these markers. So you have to take that into consideration. But if you look at creatine monohydrate, it actually is the creatine form that has the lowest conversion to creatinine from all the variations of creatine we have on the market. Because a couple of years ago, we had a supplement called creatine ethyl ester, which actually showed to have 35% conversion from creatine to creatinine. And that's why you don't see a lot of creatine ethyl ester anymore after that study, because a lot of the companies, they actually stopped selling it because of the high conversion of creatinine from that supplement. But creatine monohydrate, I think, is like there's 1% conversion from creatine, and compared to creatine ethyl ester that had I think it was 36% conversion. So quite a difference between the two.
Is that why that's the creatine of choice then, in terms of it, both because of what science has proven of the other one, and then obviously with the other one being so efficient on top of obviously your protein synthesis with either getting it from a raw format as well as from a whey alternative as well?
Well, if you look at the research, there's like over 200 studies showing that creatine monohydrate is effective. It's also most research creatine form, the cheapest creatine form, and to this day, there hasn't been a creatine variation that has been shown to be better than creatine monohydrate. I think people are a bit misguided when people talk about like the different forms of creatine, because a lot of people would say, well, creatine monohydrate is the only creatine that works. Well, that's not true, because there's studies that have looked at crealkaline and other variation where they see that it actually increases creatine phosphate levels. But the problem is that none of them has shown to be better than creatine monohydrate. So the question is, why would you pay 3-4 times the amount for a creatine variation, like a creatine form that's not showing better results than creatine monohydrate? So I think the study by, what's the name of the guy? Jager, I think the name of the researcher, they compared creatine monohydrate with crealkaline. And what they saw was that, well, both of them increased creatine phosphate levels, and both of them got effects on body composition and strength, but there wasn't crealkaline wasn't better than creatine monohydrate.
But for this penultimate question to Juma, then why isn't there the same basis for what you just mentioned with creatine when it comes to whey then?
In terms of
being
digestion?
Not from a digestion perspective, but be it one whey being better than each other based on, marketing will say this product's better than that one. Do you think that we need more research to kind of say definitively this is the best form of whey, irrespective of price?
Well, there has been some research recently looking at what's known as native whey that has a higher leucine content than like regular whey. I think it was whey concentrate 80 that was compared to WPC compared to native whey, and the difference was whey concentrate was 8 to 10% leucine, and native whey was 10 to 12. So the researchers, I think the hypothesis was that native whey would be better due to the higher leucine content. What they actually found in the study was that there wasn't any difference, because as long as you reach a level of leucine, like more leucine is not going to do anything. Like you reach a level and then you max out, and everything above that is like, it's not necessary. That's why we always also tell people that when it comes to protein intake, because some people say, well, if I need 200 grams of protein, why can't I just eat that in a meal instead of like trying to divide it? Because what happens then is that some of that protein will go to protein synthesis and muscle growth, and then the rest of it will just be converted to glucose and stored as energy or used as energy. So it turns into expensive energy in that way, because you have a ceiling to how much protein can go to protein synthesis and muscle growth, and then the rest of it doesn't get peed out like a lot of people think. It just gets converted, because the body will, when the body gets a huge intake of protein, some of it will go to protein synthesis, and then the body will down-regulate digestion, so it's able to absorb the huge amount of protein, and then it will start to convert the protein that aren't used for protein synthesis to glucose, and either it's used as energy or it's transported to the liver and stored as glycogen, or transported to other tissues in the body where it can be used as energy.
So my final question to you, Juma, like I like to ask all my guests on the show, is if you had to summarize what we've been speaking about today, for you it's going to be quite difficult because it's quite long, into one sentence for somebody to take away, what would that be?
Well, I think since we covered so many different topics, I think the most important topic that we discussed was the topic of energy balance and weight loss. And what I would say about that is, when you're trying to lose weight, you should always try to think of sustainable changes that you can do to keep the weight off. Because if you keep on trying to do these crash diets, you will just end up making it harder and harder and harder for yourself each time you try to diet down. So always, when you're trying to lose weight, try to always have a strategy to what are you going to do after you lost that weight. Because getting the weight to your target, that's not the difficult task. The difficult task is, how do you sustain that weight loss after you lost weight? And if you, from the start, have a very strict diet strategy, it probably will be very difficult for you to follow that in the long run. So, example, a lot of people, they eat chicken, rice, broccoli several times a day to lose weight, and then it might help getting the weight off, but it's going to be extremely difficult to sustain that eating pattern in the long run. I know from personal experience, because I got burned out on chicken breast many years ago when I was eating like 3 times a day. I was eating chicken, rice, and broccoli, and I just ended up hating eating chicken. So nowadays I'm able to eat chicken again, but I'm never going to go back to eating it several times a day. And one reason is that you get sick and tired of eating. The other thing is that it doesn't create a lot of variety in your diet, so it's actually harder to get in all the micronutrients that you eat. So that would be my take-home message from this podcast we had today.
So once again, Juma, thanks again for coming on the Mindset Athlete podcast.
My pleasure. Thank you so much for having me.
Oh, it's been my pleasure. If you like this episode, please do share it with your friends, and do let Juma and I know what you thought of the episode by tagging us over on Instagram at Coach Juma Iraki. So that's Coach JUMAIRAKI, and at James O. Roberts 11. And again, you can do the same on Twitter and Facebook. And in addition, if you had any follow-up questions, don't hesitate to shoot them over as well. And finally, don't forget to check him out on his website, www.jumairaki.com. And as always, do check out my free content at fitamputee.co.uk and click on the tab Resources. But not forgetting, I've also started a new Facebook group, especially for the podcast, which you can find by typing in The Mindset Athlete. And last but not least, I've also rebranded my other Facebook group to Adapt, Master and Improve Your Exercise and Diet to help you lose 10 pounds plus. So make sure to check those links out. The links will be in the description. You can find all the show notes at mindsetgame.lipsum.com under the category Nutrition. So once again, thanks for listening, and I'll catch you next week for another episode of the Mindset Athlete podcast.